The secret to getting good at systems design is learning the basics and studying use cases, like how major companies apply these basic concepts to build their system. We're going to be going over some of the major concepts used in designing globally available and reliable and very scalable systems. The first concept that we're going to go over is what a distributed system is. And a distributed system is nothing other than a system that has its components living on different server or different nodes. So for instance, you have a system and your backend application is living on one server, your front-end application is living on another server, your database, your cache, CDN, and every other thing that you use are all living on different servers, and that is what makes a distributed system. The next concept we're going to be talking about is scalability. And scalability is the ability of your system to be able to handle high demands. For instance, websites like Amazon.com handle millions of requests per second. That takes a lot of planning and a lot of design to execute. So the ability of your system to be able to scale to a very, very large level is what we call scalability. Also, the next concept is availability, and availability is defined as the probability of a system to stay awake while it is needed. Okay, so availability is defined as the probability of your system to work as required when required to. And today, most systems are required to work round the clock 24/7. But we know that systems are not reliable, or computers, hardware are not reliable. But still, you need to make some patches and do some things to ensure that your system is available. That's another major concept that you need to cover in systems design. The concept I enjoy talking about is reliability, and reliability is simply the probability of your system to stay awake after taking a hit. For instance, if one of your server goes down, what are the chances that your entire system goes off the grid? And your system can only be highly reliable if some things have been put in place to make sure that it is indeed reliable, such as redundancy, adding a new server to make sure that when one server goes down, your entire application is still up. Another concept to really grasp is the client-server relationship. In most systems designed today, there's usually a client and usually a server, which is like a front end or a back end. Your client is usually your web browser or your mobile application. It could be your terminal where you access your API endpoints. And then your server is usually your business logic that's connected to a database and is deployed on some server, either in your room or on an AWS service. And the relationship is that the client makes a request to the server, and then the server could either authenticate if it requires authentication. The client could authenticate if it requires authentication and send back a request response back to the server, back to the client rather. Yeah, so there's that part. And yeah, that's basically the client and the server. So they have a relationship. The client makes requests and the server validates the request of the client and send back a response, an appropriate response. And another thing I would like to talk about is a load balancer. A load balancer is a very, very interesting concept to cover. And what it majorly does, it helps distribute traffic or load amongst a number of servers. So this is usually not for a small project that you have just one server. It's usually for a project where you have multiple servers, minimum of 2 servers, you would imagine. And you would want to distribute the load depending on the capacity or strength of one server, or you could as well evenly distribute it. The load balancer also ensures that your server is up all the time. So if a request is going to one server and for some reason it fails, it will redirect it to the next available server, and a lot of things in place that the load balancer does to help your system stay alive. And cache is king. The next concept is cache, and what a cache is basically is a data storage that is closer to your client, in the sense that imagine you I'm trying to find a great example to explain this, and a very popular example is the librarian and the book example. So imagine you're a librarian and there was a particular book that was always high in demand, but the book is originally stored at the end of the library. It would make sense for you to bring that book to your table, in fact, so you would not have to make that journey to go and get the book. That's exactly what a cache does. A cache is a data storage that stores highly requested data, so that you don't have to make a request to your original database. So yeah, that's basically what a cache does. And for this video, I'm going to talk about the last concept, which is a CDN. And a CDN stands for a content delivery network, and is majorly used for storing static files such as your images, your static JS files, JavaScript files, the static CSS, and even static HTML files. So files that are write once, read many. I think that is it. Write once, read many, and you don't change them like your image. Obviously, you're not editing the content of your image. An image is not going to show one content today and show another content tomorrow, except I don't know what case that will happen. And static CSS that you are not changing anytime soon should be stored in a CDN. And a CDN is a network of servers that store static information.